Hi students, this is just a quick tutorial to hopefully help those who are struggling to create an accurate recurrence relation for their superannuation in the PSMT. I'll just quickly recap what a recurrence relation is, and we'll talk about arithmetic and geometric sequence recurrence relations, and then I'll move on to more complex sequences like your superannuation. So a recurrence relation describes the pattern in a sequence by relating each term to the previous one. We've had a look at arithmetic sequences so far and geometric sequences. In an arithmetic sequence, the recurrence relation says Tn plus 1 equals Tn plus d. And because the little subscript n and n plus 1 here refer to the position of a term, this is really clearly relating the next term in the sequence being equal to the current term plus some common difference. So an example of a recurrence relation that would actually work to describe a real arithmetic sequence would be perhaps one that says T1 equals 0 and then Tn plus 1 equals Tn plus 4. So this is describing a sequence that starts with the number 0 and then continually adds 4 to that number. So very clearly that would be 0, 4, 8, 12, and so on. And that sequence could continue forever. A geometric sequence, we studied these in class as well. They have the recurrence relation saying Tn plus 1 is equal to Tn times r. And so the difference here is that instead of d for the common difference, we have r representing the common ratio, because what a geometric sequence does is it continually multiplies by the same number over and over again. So an example geometric sequence would be T1 equals 2 and Tn plus 1 equals Tn times 3. And that would describe a geometric sequence that starts with the number 2 and then continually multiplies by 3, because our recurrence relation here is saying to get to the next term, take the current term and multiply it by 3. So this sequence would go 2, and then 6, and then 18, and then so on. It would continue in that same pattern, continually multiplying by 3 to get to the next term. Those are the types of sequence we studied in class. But as you've probably realized, superannuation is more complicated than just an arithmetic sequence or a geometric sequence. There are things that we add into our superannuation account because we add a deposit in, but also we multiply to find interest or perhaps to find how much money is left over after the fees at the end of the year. So there's a combination of multiplications and additions occurring. So I will just show you that more complex patterns can be turned into recurrence relations as well. We just need to be able to write one sort of phrase that says Tn plus 1 equals and then describes what happens to the previous term. So I've got an example pattern here that I've just pre-written. Starting with the number 4, we're going to complete this 3-step pattern over and over again. We're going to multiply by 4, we're going to add 5 to the result, and then we're going to divide the result of that by 7. So what we're describing here is a sequence that starts with T1 equals 4. That's just because my starting term is 4. And then my recurrence relation is going to have to say Tn plus 1 equals, and I'll just start with Tn over here. And then we're just going to have to step by step apply those three aspects of the pattern to our recurrence relation here. So the first thing that happens is it multiplies by 4. So I'm going to write 4 times Tn. So that's the first thing that happens in my sequence. Then I add 5, so I add 5 to the result of that. And then I divide the whole thing by 7. So obviously this is a time where order of operations becomes important to us, because if I just write divide 7 on the end here, well then that's really saying add 5 divided by 7. So only the 5 would be divided by 7 in this case. So here we just need to bring some brackets in, and there we go. We'd have a completed recurrence relation here that describes a nice sequence for us. So it starts with 4, and then the pattern is saying multiply that by 4, add 5 to the result, and then divide by 7. So this would describe a sequence that goes 4, and then I'll just very quickly do the working on my calculator. I'm multiplying that by 4, so 4 times 4, adding 5 to the result, and then dividing by 7, and that then gives me 3. And then I could do the same thing again, apply that same sequence on my calculator. So now I have 3 as Tn, so I'm saying 4 times 3 plus 5, and then dividing that result by 7. And this time I get a decimal number. I get 2.42857. Okay, and then the sequence would continue from there. So fortunately, the sequence started with 2 integers, but then it very quickly is going to devolve into some decimals from there. And in the same way, your superannuation sequence is unlikely to continue returning whole numbers to you. So what you need to do with this information is recognize that your superannuation follows a pattern similar to this as well. We have some kind of amount in our first year, which you could call T1 or you could call it T0, because it's the starting amount at 0 time being passed. And then we need to recognize what happens to it to get to the amount that I have in my super after 1 year. So this is after 0 years, and this is after 1 year has passed. And if we can kind of just discover what happens in that first year, and then generalize the pattern from there, we can also create a recurrence relation for superannuation. So obviously, you've all done some research, you've read the task sheet quite well, you've indeed done your modelling on Excel, most of you. You've recognised that essentially 3 things happen to your super each year. 1, it grows with interest, and that's a multiplication. 2, it grows when you deposit more money into it, so that's a plus. And then 3, the fees are taken out. And we can represent that as a multiplication or as a minus, because we could work out what the fees are and then just subtract them away. In the same way, we could also represent interest as a plus if we really wanted to as well. We could calculate what the interest is, and then we could just add that onto the amount. So what that means is you need to come up with some kind of recurrence relation that describes these 3 things happening to go from Tn to Tn plus 1. So you need to kind of fill in all the blanks here. What happens to Tn in order to find out how much money we have in our super at the end of a year passing? And then that pattern should hold every year from then on out.